What if you could prevent Microsoft Flight Sim's VRAM filling up completely just by downloading a $5 program? While DLSS Frame Generation users watch their memory max out mid-flight and impact their performance, thousands of simmers are maintaining smooth performance with a tool that wasn't even built for flight simulation. Across the Flight Sim community, we're seeing RTX 30 series and even lower-end 40 series users reporting better stability than 4090 owners. The reason? A third-party frame generation tool that handles memory completely differently to DLSS. We've spent the past 3 weeks measuring exactly what's happening here and why so many users are using Lossless Scaling as their preferred tool for Microsoft Flight Sim 24. We've compared frame times, memory patterns, and GPU utilization across a multitude of flights, and the data reveals why this solution has been gaining so much traction in the community and exposes a fundamental issue with how Microsoft Flight Sim 24 manages memory. But before we dive into our findings, it's important to understand how both DLSS Frame Generation and Lossless Scaling work, and why they might affect Microsoft Flight Simulator 24 differently. DLSS Frame Generation primarily operates as a deeply integrated component of the rendering pipeline, working directly at the engine level of Microsoft Flight Sim 24. Unlike external tools and solutions, DLSS Frame Generation has access to key game engine data. For example, it has access to motion vectors, which are directional guides that tell the GPU exactly how each object is moving from one frame to the next. In addition to this, FrameGen also has access to depth buffers, which tell frame generation how far each pixel is from the camera by providing exact Z buffer data. This data is really key for simulators such as MSFS 24, as it provides accurate frame interpolation where depth perception and distance are really important. Think about when you're landing, for example. Finally, FrameGen has access to object velocity data, tracking the exact speed and direction of everything within the simulator. So what this all means is that essentially frame generation is able to construct interpolated frames with better accuracy. When it generates a new frame, it's not guessing, but instead knows exactly how each scene is moving simultaneously. It will be able to accurately predict the rotation of your aircraft, the movement of the clouds at different altitudes, and even the movement of cars, ships, or animals on the ground, all while maintaining correct depth and perspective. Now, I should mention that there has been a few videos published showing how to use DLSS 4 frame generation in both MSFS 2020 and 24. Our early testing suggests this has introduced significant improvements to both stability and image quality. We'll hopefully have a dedicated video comparing DLSS 4 versus the original frame generation soon, followed by a complete performance analysis of the Sim Update 1 beta. So make sure you're subscribed for both of these videos so you don't miss out when they drop. However, for this video, we'll be focusing on the frame generation that was originally implemented in the sim, as its memory behaviour reveals some fundamental issues with how MSFS 24 handles VRAM, issues that are still relevant even with DLSS 4. But, getting back to how these technologies work, Lossless Scaling operates in a fundamentally different way to DLSS FrameGen. As it's a post-process solution, it works entirely outside of MSFS 24's engine, only seeing what you see on your display. It isn't able to see motion vectors, and it doesn't know anything about object velocities. Instead, what Lossless does is work purely on the completed frames after they've been fully rendered. Essentially, it looks at two finished images and tries to figure out what should exist between them and fill in the gap. To do this, Lossless uses machine learning algorithms to analyze these completed frames and generate new frames based solely on what it can observe from the final output. At first glance, this might sound like a huge disadvantage, but in actual fact, this simpler approach provides unique benefits to MSFS 24 given its current state. In theory, because Lossless operates entirely outside the rendering pipeline, it's completely isolated from the simulator's internal memory management. It doesn't require extra VRAM for motion vectors like frame generation does, and it isn't affected by the simulator's own memory allocation patterns. What it results in, though, is a lighter touch on system resources, which, as our testing will show later on, leads to better stability overall. So now let's look at the performance data we collected during a flight between Boston and Newark, using the Phoenix 319, GSX and Navigraph. We chose this route to stress test both technologies due to the tree density, rock formation and dense urban environments. Likewise, we chose to use GSX, Navigraph charts and the Phoenix A319 as this represents a typical setup that most simmers use. With frame generation enabled, our testing revealed an average frame time of 9.67 milliseconds, with variation between 7.75 milliseconds at the first percentile and 17.14 milliseconds at the 99th percentile. To put these numbers into context, what this meant was that the simulator was averaging at around 103 frames per second, thanks to the 9.67 millisecond frame time, but the actual experience is far less consistent than the average suggests. What we noticed was that while the best 1% of frames were rendering in just 7.75 milliseconds or around 129 FPS, the worst 1% took 17.14 milliseconds, dropping the average FPS to 58. In addition to this, when we looked at our GPU utilization, Frame Generation consistently pushed the RTX 4070 Ti to 96.65% utilization. The graphics card was running at near maximum capacity almost constantly. In fact, our testing revealed that Frame Generation pushed the GPU above 95% utilization for a staggering 85% of total flight time. So for nearly 51 minutes of every hour of flight, the GPU is running at near maximum capacity. In traditional gaming, this would be fine. But when you consider all of the extra background tasks for Microsoft Flight Sim 24, having just 3.35% headroom becomes a huge problem. When Frame Generation needs to handle unexpected events, whether that's loading in new terrain data, processing weather updates, or handling aircraft systems, it's attempted to do so with a GPU that's already operating at near capacity. It's akin to trying to add more cargo to an already fully loaded aircraft. Something's got to give. Even the Phoenix A319 systems require constant GPU and CPU compute times, which meant it was having to fight for the limited scraps it had for resources. Lossless's more conservative GPU utilization means it had significantly more headroom available for these background tasks. When GSX needed to spawn in new ground vehicles, for example, Lossless can allocate these resources without pushing the GPU into overdrive, which translated to fewer stutters and more consistent performance, even if the baseline performance is lower. And when we looked at the second-to-second GPU utilization, we saw that Frame Generation's GPU usage had rapid fluctuations between 95 and 99%, creating a sort of sawtooth pattern in our performance graphs. Lossless, on the other hand, maintained a more stable utilization curve, typically hovering around 87%, with gradual transitions when demand increases or decreases. And to add to all of this, the memory behaviour for Frame Generation told a similar story. Peak VRAM usage hit 11.71 GB, but we also documented 48 significant memory spikes throughout our test flight, with significant defined as sudden changes exceeding 100 MB within a single frame interval. And these spikes followed patterns that correlated with specific events. The most dramatic of these occurred when we transitioned to a saved camera position, where we recorded the largest spike of 960 MB, effectively requesting almost a gigabyte of VRAM instantaneously. And what was even more interesting was how these memory spikes compounded within the simulator's memory. When we examined our long-term memory plots, we noticed a gradual upward trend in baseline VRAM usage, suggesting that not all allocated memory was being properly released. For example, if you imagine doing a long haul, for example, or you were just doing a simple rotation, this cumulative memory buildup would eventually impact your sim's performance. So to verify this, we conducted another test, a 3-leg rotation between Boston, Newark and Philadelphia. We started with a clean simulator, having cleared the rolling cache and scenery indexes, and our baseline VRAM usage began at just 9.2 GB. But by the first leg, this crept up to 10.1 GB, before eventually reaching 11.2 GB by the start of the third leg. This progressive increase in baseline usage had a huge impact on overall performance too. Those same 100 MB spikes we mentioned earlier now had a much more pronounced effect, as the buffer for handling these sudden memory requirements became increasingly restricted. Essentially, where Frame Generation could previously handle these requests with minimal impact, we now saw noticeable stuttering and performance hits during camera transitions or when loading in new scenery. However, perhaps the most telling thing was the frame time consistency between legs. During our first leg, frame times stayed relatively consistent outside of the documented spikes. But by the third leg, we noticed much more variation, even during cruise, suggesting the Frame Generation was simply struggling to maintain consistent performance with the reduced memory headroom. So what about Lossless? Was performance much more consistent when using it? Well, our testing revealed some counterintuitive results. Lossless showed higher average frame times at 28.31 milliseconds, nearly 193% slower than Frame Generation's 9.6 milliseconds, but the raw numbers don't tell the whole story. When we looked at GPU utilization, Lossless maintained a much more conservative profile, averaging just 87.41%. What this meant was that we had roughly 10% more headroom available for background tasks over Frame Generation's dismal 3.35%, and as a result we saw much better overall performance. When GSX needed to load in ground vehicles, it didn't have as much impact compared to when we used Frame Generation. Even the Phoenix's systems had extra GPU resources available to it, resulting in fewer conflicts for resources. But it's the memory behaviour itself where Lossless really showed its strengths. Peak VRAM usage topped at 10.73 GB, nearly a gigabyte less than Frame Generation. More importantly, our frame-by-frame analysis recorded only 22 significant memory spikes throughout the flight, less than half of what we saw with Frame Generation. So when we repeated our 3-leg rotation test, baseline VRAM usage began at 9.62 GB, increasing to 9.85 GB before hitting at around 10 GB after completing all 3 legs. There simply wasn't a continuous creep up of VRAM usage like the one we observed with Frame Generation. However, while these memory and utilization patterns paint a compelling picture for Lossless, we do have to address the elephant in the room, which is input latency. Our testing revealed some differences here, with display latency averaging 47.93 milliseconds when used in Lossless compared to Frame Generation's 20.32 milliseconds. But when we look deeper into the numbers, Frame Generation showed extreme variations in its latency. While it could achieve impressively low latency with an average of 20.32 milliseconds and dropping as low as 6.52 milliseconds in best case scenarios, we recorded spikes of up to 1199.25 milliseconds. That's almost a 1.2 second delay. Lossless, on the other hand, despite having a much higher average of 47.93 milliseconds, maintained a much more consistent range. Latency never dropped below 21.25 milliseconds or exceeded 316.38 milliseconds during the worst spikes. What this meant was that while Frame Generation could deliver much better control inputs on average, the experience was far less predictable. The latency spikes we encountered often coincided when we saw memory and GPU utilization issues, like when the simulator needed to load in new scenery, and so we paid particular attention to how this affected landing aircraft. During our approaches to Newark, Frame Generation's often unpredictable latency made some difference when we wanted to follow the ILS glide more accurately. One moment the controls would feel quite snappy, but then it wouldn't feel as responsive, which meant those small minor adjustments weren't as accurate to stay on the glide slope. Lossless by comparison gave us much more predictable handling despite its higher latency. Yes, based off the latency data we collected, it was much higher than Frame Generation's. However, the predictability Lossless gave us meant we had a much more reliable feel for the controls. There wasn't any sudden changes in sensitivity to compensate for, just a consistent response time. Of course, Frame Generation clearly offered better raw performance, but Lossless provided a more stable, predictable experience overall, and it's a pattern we've encountered throughout our testing. On the one hand, Frame Generation shows superior numbers, but on the other hand, Lossless delivers more consistent performance. At least that is based off of right now, and with MSFS 24 in the current state it's in. Frame Generation without doubt offers technically superior image quality. However, it also inadvertently amplifies the simulator's existing VRAM issues. Some users have shown VRAM consumption as high as 18.5 GB, even RTX 4090s struggle with the simulator on occasions. So understanding these trade-offs becomes even more important when deciding which solution works best for your setup. Don't get us wrong, Lossless isn't without its visual compromises. In fact, we documented several artifacting issues due to its post-process technology. Moving the drone camera around static aircraft on the ground showed us a distinct melted light distortion, particularly across transparent surfaces like cabin windows. Overall, Lossless simply isn't able to achieve the same level of clarity as Frame Generation achieves. That being said, when we consider actual flying, Frame Generation's superior image quality comes at a cost for overall stability. In our 3-leg rotation, VRAM usage climbed from 9.2 GB to 11.2 GB, not through sudden spikes, but via a gradual accumulation that the simulator never managed to clear. And this in itself matches exactly what users across the community have been reporting: a slow but persistent increase in VRAM usage that eventually impacts performance. Overall though, it's easy to see why some flight simulators are using lossless as a viable alternative. Yes, it comes with visual compromises, such as the artifacting that we documented earlier, but the overall consistent reliable performance, particularly on GPUs with 12GB or less VRAM, makes it an attractive option given MSFS 24's current state. That being said, frame generation still holds a clear advantage in some scenarios. On higher VRAM cards like the RTX 4090 or AMD RX 7900 XT, where the VRAM ceiling is less likely to be hit, frame generation's superior image quality might be worth the trade-off. Likewise, on shorter flights where memory accumulation has less time to impact performance, frame generation's better clarity and more precise motion handling is a solid choice. But ultimately, your choice is likely to boil down to your specific setup and preferences. As MSFS 24 continues to evolve and improvements are made to memory usage, these recommendations are bound to change, but for now at least, Lossless offers a practical solution for users prioritizing stability over visual fidelity, or those particularly affected by the simulator's current memory management issues. With DLSS 4 frame generation and Sim Update 1 now released, this is definitely a positive step forward. We'll be diving deep into both in upcoming videos to see if they fundamentally change memory behaviour or whether they just paper over the cracks. So don't forget to hit the like and subscribe button so you don't miss that. And of course, let us know in the comments your thoughts on Lossless. Do you use it for your simulator, or are you sticking with frame generation for now? And we'll see you in the next one.